Question 3b. Use mathematical induction to prove that, for integers n greater than or equal to 1, 1 times 3 plus 2 times 4 plus 3 times 5 plus ... plus n times n plus 2 equals n over 6 times n plus 1 times 2n plus 7. The first step is to show the statement is true for some value of n. And in this case, the smallest value of n that we can test is n equals 1. Now when n equals 1, the left-hand side of the statement equals 1 times 3, which equals 3, and the right-hand side of the statement equals 1 over 6 times 1 plus 1 times 2 times 1 plus 7, which equals 1 over 6 times 2 times 9, which equals 3. The left-hand side equals the right-hand side, hence the statement is true for n equals 1. Next, we assume the statement is true for n equals k. That is, 1 times 3 plus 2 times 4 plus 3 times 5 plus ... plus k times k plus 2 equals k over 6 times k plus 1 times 2k plus 7. Next, we show the statement is true for n equals k plus 1. So from the left-hand side of the assumption, we have 1 times 3 plus 2 times 4 plus 3 times 5 plus ... plus k times k plus 2 plus k plus 1 times k plus 3, which equals k over 6 times k plus 1 times 2k plus 7 plus k plus 1 times k plus 3. And that's from the assumption, since we can replace these terms of the series with the right-hand side of the assumption. Now factorising k plus 1 out of both of these terms, we have k plus 1 outside of k over 6 times 2k plus 7 plus k plus 3. Which equals k plus 1 times 2k squared over 6 plus 7k over 6 plus 6k over 6 plus 18 over 6. So I've expanded the brackets here and expressed all of the terms with a common denominator of 6, which means we can factorise 1 over 6 out of the square brackets. So that equals k plus 1 over 6 multiplied by 2k squared plus 13k plus 18. So we have a non-monic quadratic there that we can factorise. And that equals k plus 1 over 6 multiplied by k plus 2 times 2k plus 9. But n equals k plus 1. So rearranging this equation, we have k equals n minus 1. So bringing this expression back in terms of n, that equals n over 6 times n plus 1 times 2n plus 7, which equals the right-hand side of the original statement. Therefore, by the principle of mathematical induction, the statement is true for all integers n greater than or equal to 1.